Hello everybody. In the previous video we looked into how AC currents are brought home from the generating station, and one thing we saw was we used to step up this voltage to reduce transmission loss, and part of reducing transmission loss was also increasing the resistance reducing the resistance, bring down the resistance, and for that we use thick wires. And it's for this reason that you see that these transmission towers are really tall and huge, because they have to support that kind of load or weight of this heavy wires. So I missed that in the last video, so starting from there, now let's look at how in this video how AC current is brought from power line to your home. In India, electricity theft is a very common problem. You will see that people illegally they tap current from the lines above, and they use electricity from these lines. So let's take a very simplistic view, and let's see how the mechanism of AC current works through this a very simple setup. So here is your transformer. So let's start from the transformer. So here is the transformer, which is your CT transformer, and this is a step down transformer. That means that on the primary there would be more coil than the secondary. So that's 11 kV, and this is 220 volts. So we usually one of the end of this transformer is usually grounded, and this we call it as a neutral line. It represents 0, and the other end is a live. We call this as a live wire, and usually it's red or brown in color, or rather there is a color coding that we use inside home, but not for transmission, but I'm just using the color code here. So this is live, and these are transmitted, right? This is how they are transmitted. So I'm using color code here to identify the neutral and the live. So here you go. So this is how the lines are coming in, and let's assume I do this illegal tapping, and I tap from these lines current, and I pass it through a bulb. So this is my bulb. Okay. Now what happens is, as in the AC current you have two cycles. You have the positive cycle and then the negative cycle. So let's see what happens in the positive cycle. So in the positive cycle, what happens is the current goes from the live, it traverses through this bulb, and it comes back, and the neutral is actually offering the return path, right? So this is the first cycle. Let's use a different color for second cycle. So in your second cycle, this is your second cycle, which is a negative cycle with respect to the reference, which is 0. So this is your neutral line. The 0 is your neutral line, right? This is your neutral. So with respect to neutral is has more potential than the live now. So what that means is, in this phase, sorry, I use a different color. So in this phase, the current is traversing in the opposite direction. It is traversing in the opposite direction, the second cycle, and it goes in. So we generally say the neutral is reference 0. It offers return path to current. It is grounded. It is it is grounded because the Earth is an infinite sink of electrons, and also it's a infinite. It can offer infinite electrons. So either if there's Earth, you can have electrons infinitely going in and or infinitely coming out. So for that reason, we usually consider the Earth, the wire which is Earth, as a neutral, or we call it it is grounded. So we say neutral is grounded, right? We say neutral is grounded, right, or earthed. Please do not confuse it with the earth wire. I mean, just like neutral wire and live wire and neutral wire, the earth wire is a different kind of wire. It's going to be used at home. But when I say neutral wire is earthed, it's different from the earth wire. So here is a summary. So the AC current is transmitted to home through two wires, which is live and the neutral wire, which both comes from the transformer. So you tap into your house to the live and the neutral, and your electrical equipment works. Now before we end, let's assume this bulb is about 110 watts. Now we know that this the live is 220 volts with reference to the neutral. So the current that you draw is given by I is equal to the power divided by voltage, or in other words 110 watts divided by 220 volts, and that amounts to 0.5 amperes. So if you connect a bulb of 110 watts, that is the amount of current that you are drawing. You're drawing 0.5 amperes, and of course this 0.5 amperes is it's both ways depending upon the cycle of positive phase or negative phase. Okay, so that's how you determine the current that you draw from the main line. So if you have in your house total equipments worth, let's say 2200 watts, if that's what you're consuming, energy per second, that's what you're consuming, the current you're drawing into your home is given by 2200 watts divided by 220 volts. That's about 10 ampere current. That's what you're drawing into your home. So in your home you typically draw about 10-15 amperes on an average, but a max of about 50 amperes. That's what you would draw at your home, not more than that. And these transformers produce about close to 100 amps, or about, depending upon what type of transformer it is. So it could be 100 amps out along with 220 volts. That would mean that it can be connected to, it can take up 10 different connections. The transformer can offer 10 different connections on an average. Each home, if it draws about 10 amperes on an average. I hope you enjoyed this video. In the next video, we will look into further details of how connections are done inside your home. So see you then. Ciao.